having us. And thank you all for being interested in the topic on how large language models helped us to revolutionize the skill distribution of Kloeckner. And yeah, for some of you, maybe Kloeckner is not a name, so let's first give you a little bit of an idea of what Kloeckner and what kloeckner.i is. This is a beautiful picture of our office where Roxana and I work together with 140 talented colleagues of ours together in the innovation lab of Kloeckner & Co. actually. And we were founded in 2014 and working heavily on automating and digitalizing the business of Kloeckner, who is one of the largest distributors of steel and metal products around the world. So in our product portfolio, there are more than 190,000 products. We have over 60,000 customers and 6,400 employees. So you can imagine that the volume of requests for orders and requests for quotes are quite high that our sales representatives are facing every day. So Roxana and I, we are working together with 20 other colleagues at kloeckner.i at a project that is called Kloeckner Assistant, who is there to help automate that process and free our colleagues time for more important tasks like connecting with our customers. And today we want to give you a little bit more of a technical deep dive in one of the main focus, the email extraction, the information extraction from emails. So let's first have a little closer look at the challenge that we took for that. So as I said before, our sales representatives are dealing with a very high amount of requests every day, and some of them are requests for quotes, others are requests for orders. And this one clearly is an email, as you can see here. But as we look at it now, what Mr. Joe Public wants here, we ask ourselves, what is it? Is it an order or is it a request for quote? So here we can easily say, okay, that's an order. And we can also really easily see, okay, he probably wants some might steel, yeah? And 12 sheets of that, and also in which time amount he wants to have that delivered. But maybe there are also more questions arising from this. So this was a very easy example. Yeah, let's look a little bit more fun one. This one. Yeah, here we have 2 emails, and there it's maybe not that clear anymore what they want and what Mr. Adams actually wants here. But as you can see, it's several positions with alternatives. So he's not sure, like, I want actually this product, but if you don't have it, maybe send me another one instead. And then he also forgot something, so he chose to send another email, which still is then represented to our sales rep, and they have to put that together, to put that information in the past manual in our ERP system. So what happened in the past when all those emails came to our sales representatives was, in order to avoid mistakes and to transfer the information to the ERP system, they sometimes even started printing it out and manually typing it into the system. So you can imagine that takes a huge amount of time, and some of them would have needed actually free hands to pass it all on. But hence, Kloeckner is trying to really reduce its carbon footprint and be sustainable, and we also would like to have our colleagues more time for building relationships with the customers. We developed Kloeckner Assistant. And how that process looks in the Kloeckner Assistant, I'm going to show you now. So let's assume we are getting, again, one of those emails. Now that email is automatically forwarded into our Kloeckner Assistant, where then the magic happens. So in the email, it can be just a text as we've seen it before, or it could have also been in PDF file. Some companies like to just attach it. Yeah, so what the Kloeckner Assistant does is mainly 3 things. It extracts information either from emails or from PDF files, and then it takes the description of the material and matches it automatically to our internal material numbers. So our colleagues in the storage units, they can easily process the information and the goods. So from then, when all that information happened to be extracted in the Kloeckner Assistant, our colleagues come back and check the information that is extracted in the Kloeckner Assistant. They give it a last look and see, hey, is it correctly extracted? And maybe there's some unforeseen change. Maybe we can even deliver it faster. So they are now able to take changes and then hit a little button to send it to our ERP system. And from there, the quote or the order can be shipped out to the potential customer. So Now this is still quite abstract, right? So I want to show you how it actually looks when it's in the Kloeckner assistant. So on the left-hand side, you can see that little email from Joe Public. And now here, you can see that the Kloeckner assistant correctly extracted that we are talking about the purchase order here, also about what material we're talking of, much, and the delivery date, and it even matched it to our internal material number. So the only thing the sales representative now has to do is click Send to ERP, and the order will be sent out. So now Roxana is going to explain you a little bit more about the email extraction process and how we actually get the information out of those emails.
Right, so our email extraction process consists of 3 different steps. First, we have our pre-processing, then we have our transformer model, which is the heart of our project, and then we have our post-processing. So in the very first step, in the pre-processing, we are preparing the text for our model. And here the main component is the tokenization. Tokenization means that we're taking the text, the entire email, and we're breaking it down into smaller pieces of text, which are a lot easier to understand for our transformer model. Then we are forwarding these tokens from our pre-processing to our transformer model. And here, the very first step is the embedding layer. So in the embedding layer, we are transforming these tokens into vectors. And these vectors are a numerical representation, which our machine learning model can then understand. And these vectors capture the linguistic meaning behind the tokens. So then we have our prediction. And here we have 2 types of prediction heads. We have our field prediction, and we have our line item prediction. And on the side of the field prediction, we are predicting several different fields, but the 3 main fields are quantity, unit quantity, and description. And then on the side of the line items, we're predicting if a token is a start, middle, or an end of a line item. And you might ask, okay, why do we need 2 types of predictions? And the answer is, it's not enough to just predict if something is the quantity, unit quantity, or description. You also need to know which quantities, unit quantities, and descriptions belong together. So if you have an email which says, I would like to have 10 pieces of steel A and 12 pieces of steel B, you need to know that 10 pieces of steel A belong together to 1 line item and to 1 entity. And the same thing for 10 pieces of steel B. All right, so after we have these 2 types of predictions, we're then taking our post-processing, which puts it all together so that can be visualized very nicely in our Kloeckner assistant. All right, so let's look at a specific example, please. Okay, here we have our email, Dear Miss Doe. I would like to order 12 sheets, 8x4x5 millimeter mild steel. And again, we have the first step. We have our pre-processing, which takes the tokens. Exactly, and here you can just see a cutout. We're doing this for the entire email, but here you can see just an excerpt. Right, and then we're forwarding it to our transformer model. In the very first step, we have our embedding layer, which we now omitted for simplification reasons. But here you can see we have a field prediction and we have a line item prediction. We're forwarding the tokens to these 2 types of predictions. And now we're making a prediction. All right, so what comes out is for every single token, we're getting these logit scores, which are unnormalized probability scores. Here in this case, you can see probabilities. And for instance, for 12, you can see that 12 is most likely to be a quantity, because here the score is 0.8, and it's higher than 0.1, and 0.05, and 0.05. And we're doing this for the entire email, for every single token. So 12 is now predicted as a quantity, because it's most likely to be a quantity. And then sheets is predicted to be a unit quantity, and the rest up until mild steel is then a description. And then we're doing the exact same thing for the line items. So here we just have 1 line item, 1 entity, so it's rather easy. But 12 is supposed to be the start. It's most likely to be the start with a score of 0.8. Then we're going through the entire email up until steel, which is the end of a line item. And then here you can see the line item, you can see quantity, unit, quantity, description, and then it can be visualized very nicely in our Kloeckner assistant after the post-processing. All right, so then the next question is, how do we measure success? So we have 2 types of predictions, 2 types of metrics. We have the model metrics and we have the business metrics. And on the side of the model metrics, we have different types of metrics, but the most important ones are the token level metrics and the field level metrics. So for the token level metrics, we are measuring the performance of the transformer model, so the tokens that come out of the transformer model. And then on the field level side, we are measuring the success or the performance of our entire entity, so the transformer model plus the post-processing. And here we have different types of metrics. We have the precision recall F1 score, and maybe just in short, precision means how many of the predicted positives were actually positive, and recall means how many of the actual positives were predicted as positive. And then the F1 score is putting it all together. Then, on the side of the business metrics, again, we have several types of metrics, but the most important ones are the number of processed documents and the number of changes in the document. So, especially the last one is our zero-touch metric, is our automation metric. So we're saying, okay, how many documents could just be sent through without making any alterations? Then we're also doing it for 1-touch, 2-touch, 3-touch, 4-touch, and so on.
Yeah, and then now that being said, of course, we do not just want to measure it, but we also had some learnings along the way through that whole development process. So now let's have a look at that. So maybe you also have some takeaways and maybe don't need to go through some of the challenges that we had. The first and most important thing, which I think most of you can also relate, is business impact comes first. So even though we are all, I would say, kind of tech geeks, kloeckner.i, and we like to develop and try out new things, it does not help if we come up with a fancy idea if it's not needed or not practical for the business. So early on, we already started having deep conversations and evaluating actually the scope of the product that we need to develop to really ensure that we are also tailoring our solution to the needs the business actually really has. Then, as Roxana already mentioned beforehand, our model is a supervised model. So it learns like a child, So also this thing, I think a lot of people can relate already if you work with data and supervised models, garbage in, garbage out, that really holds up, Our labeling team is big and they are doing their best, but as you saw earlier, and that were not even the most difficult examples, it's challenging. Sometimes even two sales representatives might have a different opinion about what the customer actually wants. So it's really important to ensure that we give the model good data to learn and to get better. And then one of the learnings that was actually quite nice is that our email extraction works quite well. So we have also the PDF extraction, and we try different things. For example, like GPT 3.8, even though we are passionate about what we develop, we are always trying to be faster and more agile to adapt to the changes the business requests. So even though we have our developments where we put a lot of passion in it and which work well by the metrics, and also by the users, it's used across our different country organizations that we're having across the world. We are looking into new solutions, and we found that GPT did not work that well in that moment and did not perform better than our own model. But just for now. So now let's also have a look at the outlook, what we are doing currently and what we are planning in the near future. So actually one thing we'll maintain, we continue with our great business exchange. So even though we are kind of a consultancy and service innovation lab for the kloeckner organizations and for all the country organizations across the world, we still continue to have a great business collaboration, and we are setting up squads to putting our labeling team and our data experts together with the business expert from the sales offices to really have that close exchange and discuss even the edge cases to improve actually the quality of the data that we are putting into our model. Hence, we are also always working on relabeling. So if we notice that some documents are difficult, then we are starting a relabeling strategy, putting metrics in place to also assure that the quality of our labeling is measured and monitored and improved over time. So this is what we're currently working on, which is very important. And then we also now just started recently to implement metrics in production. There's that thing that the statistical distribution of your input data can change over time. Maybe the customers change their requests, and that needs to be monitored, because otherwise, if we do not monitor it, we will not detect it. And then it's like as I said before, that model is like a little child. It learns something, but now if the things change, maybe it's good to adapt, but maybe it's not so good. And then we need to understand why maybe our metrics are dropping and what we can do to improve it. So we are just recently started introducing metrics in production. And we are also, of course, still as the big players continuing to put out larger models and more powerful models. We also always monitor that if that might be a solution for us as well. That being said, it's a lot of fun to work on it. We enjoy it a lot. We hope that you could also take some learnings away from this. We want to thank our colleagues that helped us with the presentation. Yeah, gave us all the feedback for it. And yeah, now it's time for your questions, and feel free to reach out to us if you want.
Okay. Thank you, Evelyn and Roxana. Are there some questions from the audience? We still have some time. So maybe you could go to the microphone, please, so we can all hear your question.
Hello, I'm Patrick, and I was wondering, you said you were predicting if the token was on the start, in the middle, or at the end of the line, right? And I was just wondering why didn't you just split it by the new lines and take the first token, like it's start of the line, the last one is the end of the line, and everything in the middle is just in the middle. What was the motivation for the prediction model?
If I got your question correctly, I think the assumption for that would be that the cases are more clear usually, but sometimes it's not so clear with us. We even needed to find a way how to handle alternatives. I don't know if you still have that example with the email chain, the second one, where there was actually in one line, then it was just one word that was actually in between, which could be mistaken also. So that's why we are labeling it like this to avoid.
Yeah, okay.
Maybe Roxana, you also want to add
the
something.
input data was more complex.
Yeah.
Okay,
Yeah.
thank you.
Okay, thanks for your question. Are there some more questions? You're welcome.
Hello. How much does it save in efficiency of doing it?
That's a very good question. So we're stepping away from measuring the exact time our colleagues need to process. So I cannot give you a number, but it's definitely to the point where the country organizations decided to use it, and to use it, we see how the use increases of it, so it saves them time and they have more time to focus on other tasks. We cannot evaluate it quantitatively, but we can evaluate it qualitatively, and since we are having that exchange with the business, we know the feedback, and the feedback is it saves them a lot of time, so they have more time for other things and can just process it through the kloeckner assistant.
And how well does it work on the second case? You showed the email after the first email. Does it work as well, or is it?
Yeah, it works, but we are also still always working, of course, on improving it. Specifically, it gets more difficult as alternatives come into game, because language is very complex, and the relationships, specifically also when it comes to the business context, the specifications sometimes are very unique. So we are always working on improving that. Thank you.
Thank you.
And we still have some time for a last question, please.
Hi, I'm Stephanie, and I would like to know which libraries did you use for the extraction of the emails, especially for the attachments, and which models did you use? I suppose you fine-tuned the model?
Yeah, so we're using transformer models, in our case BERT. So in the beginning, in the POC, we tried different types of models. This was back then the best one. We also tried a spacey model, which was our benchmark, but in the end we decided for transformer model for BERT, and there we used the uncased one.
And the libraries for the...
Come again?
which libraries did you use for the...
It's a Hugging Face library.
Okay.
Thank you.
Some technical questions. So maybe one last question from my side. You still showed us the process and that you can automate relatively far, but still there's the man in the loop who has to put the button and say, send it to the ERP.
Yeah.
Is it possible, or could you imagine to overcome this step, so to make it a whole automation process and no one has to click the button?
I mean, it's a very good question as well. It's a very challenging point, and I mean, those business. I think there will always probably be a last oversee. I think that's also good, at least as long as we're also having metrics in production to have that feedback. So maybe in the far future, but very far. But until this happens, there are also a lot of business changes that come in quite quickly. So it's not just a technical thing. It's also sometimes, and this is what we like to have them focus more, right, on the customer relationship. And sometimes they know them very well. Maybe they can make them a different offer, add some additional items to the order. So those are also considered changes. No, so to have the last person is actually really important, and yeah, it's also a good chance for the sales representatives to connect.
So we will see how everything is evolving, and maybe next year you can present.
Maybe we
us
come back.
So once again, thanks Evelyn and Roxana for your talk.
Thank you so much.
Thank you.